This is the first lecture on the immune system, and we want to focus first on what we call the innate defenses. We have innate defenses, and then we have adaptive defenses. So the innate ones are probably at least one of them you've started learning since you were in elementary school, and that's your skin. And the skin actually has a few different factors to them that help fight off invaders. Number one, the pH of the skin is really not conducive for viruses to live on it. And second, we also have a coating of bacteria on all our skin. And a lot of people are surprised to hear staph, which is one of those ones you know is something you don't want to have, a staph infection. Staph is always living on our skin, so to a certain degree, that's one of those defenses that's there that helps take care of other factors. And the skin also has enzymes on it that help with fighting off invaders. We have a substance called sebum, and so it's one of those things that a lot of new mothers know about because the scalp can have this coating of a rather thick coating of sebum on it, and they call it cradle cap. And there's usually a little brush is given to the new mother in the hospital so she can scrape along the scalp and remove some of the sebum layer because we don't want too large of a layer on that. But our sebum oil in our hair is an important factor for eliminating some sort of invaders. And then in our eccrine, which you learned about in the when we did the integumentary system, we have chemicals within that. Your eccrine, deranicidium, for example, that is actually toxic to bacteria. And that's another factor. So highlighting your skin, you have that pH enzymes that are naturally there, and then fighters that are in our sweat as well. And then the other innate surface fighter is the mucous membranes. And so those are in our eyes, our nose, our mouth, our GI tract. And we have those, we can divide those up into two groups also. Mucin, which is thick in water, and it sticks to the digestive and the respiratory, and with saliva it washes out those microbes. So that would be when you've come in contact with something. For those of you with allergies, you know that's one of your body's defenses as you start sneezing, is that the pollen is recognized as not something that your body wants, and you sneeze that out. And the droplets can actually be quite water-like. In your saliva, of course, remember there as a review, we have 5 different salivary glands, and those are also not just important for digestion, but they're also put fluid in there that help with the microbes. And besides the mucin that's in that mucous membrane, we also have defensins, which is DEFSINS. And again, that's going to be found, it's like a defensive system, defensins. It's found in the mucous membranes as well. And it's antimicrobial peptides or proteins that you will find in there. And it also helps with inflammation response. So if you've got, something has happened to your skin, like you get a splinter, your skin recognizes that that is a foreign body, and it actually gives an inflammatory response there, and it causes swelling and the redness, etc. And so not only are those bringing white blood cells there, that's also one of our defenses, that inflammation system is. And I guess this would be a very good time for me to just interject that when you have a small skin surface infection and you're seeing that white pus, the pus itself is not bad. That's white blood cells that are there fighting off whatever is the invader. It's just we don't like that substance there. So again, because I don't have my chalkboard, my whiteboard behind me, in your innate surface defenses, you have your barriers, which is the skin and the mucosa membranes of the digestive tract, the nasal passages, the mouth. And then we're going to have a second category of those, and those are the internal defenses. So with the internal defenses, we have a lot with phagocytosis, or engulfing and getting rid of material. We have natural killer cells. We have number 3, again, that inflammatory response or inflammation, it helps here. 4, just like was on our mucous membranes, we have antimicrobial proteins that work there. And strangely enough, we go back to what I've brought up a couple times in the course, fever. So as far as our innate defenses, we have two surface, our skin and mucosal membrane. And then now we have 5 with our internal defenses. We have phagocytosis, we have natural killer cells, we have inflammation, antimicrobial proteins, and fever. And the fever, again, is one of those things that if you're that parent and you take the temperature of the baby and it's 102, 103, your almost immediate response, if you're the first young mother or father here, is to get a hold of the pediatrician and ask, is this an emergency room visit, especially with the COVID-19 virus going on. And generally will probably tell you no, let's try to reduce the fever a little bit if the baby is really fussy, because one of the important pieces here is that the baby needs to get enough rest for their body to be actually able to fight off things that are invading it. The good piece about the fever is it's an indicator of your body manufacturing white blood cells. So in one way, the fever is not a bad thing. It's just an indicator that something is going on. So I always try to rule on the side of a low fever is not such a bad thing if it's there for a day or two. Probably let it run its course, but when it does get up to that 103 mark in a child, that's when you're going to be wanting to talk to the pediatrician and making sure they want you to give Tylenol to that. But again, fever is an immune response, and that's why it's considered one of your 5 innate defenses. And then we have a totally different category that are called adaptive defenses, and that's going to be a second lecture for us. So let's spend a little bit of time with your internal defenses, because remember, highlight innate ones was our skin and the mucosal membrane. And in the skin, we had pH that was not conducive to bacteria. We have enzymes on there. We have a protective sebum coat. And then we have the protein dermatidion that's in your eccrine that helps to fight off the bacteria. And then the mucous membranes, we have the 2 big categories there, mucin and defensins. And in the mucin, it's in water, it becomes thick, and it's like it helps clog up so that invaders can't get inside the body. It's one of those first lines of defense. Remember, we have the hair in our nose. Now we have also linings that you're finding out about. And again, that would be a digestive, respiratory, even in your saliva. And then the defensins are, again, in your mucous membrane, and they can secrete to the skin antimicrobial peptides. They help with inflammation, and they help control bacteria and fungus. And fungus is one of those strange ones that most physicians will tell you that the average body has at least 6 different types of fungus on it. Back in 2011 or 2012, Brigham and Women's in Boston started to do a fungal study where they came up with a biotech piece of equipment that sort of looked like a asthma inhaler. And all the patient had to do was blow out, and it would identify the fungal flora that they had inside the respiratory system and mouth, etc. I've been curious as to how that trial went. But of course, that's fungal infections. If a person is in an immune system disorder, can be very dangerous. And then we have the normal funguses that we're sort of used to, athlete's foot, and then yeast infections. And then we have things like ringworm, which is also a fungal infection. And your defensins help against all of those. So when we start to look at the internal defenses, our first one is phagocytes. And your phagocytes are a type of neutrophil or a type of white blood cell. And we have 2 big categories of those. And out of our white blood cell phagocytes, we have our free macrophages or macrophage. I actually heard it pronounced that today. I was kind of like, oh, wait a minute. And I had to go on and double check that both pronunciations are acceptable. So I still prefer macrophage, so I'm going to stick with that. So we have a free macrophage that is going throughout the bloodstream, and then it would travel through the interstitial spaces, that fluid, and they would go to where they're needed, where there's a communication that they have some sort of a infection. So, and then we have a fixed macrophage, and those you're going to find in the liver, where, again, this is one of our big filters. So, and then another thing that the phagocytes, because you think of them as like being an engulfer or a large, I don't want to call them Pac-Man so much, but a large force that can engulf something and help get rid of it. They oftentimes will merge with lysosomes, which we know have digestive enzymes within them, and they'll bond with them. And we also have another natural killers. And natural killers are the ones that some families just seem to have more of. I probably should talk about opsonins first. Some of the phagocytes can't work on their own if they come across certain pathogens that don't have a protein coat that is recognized. One of the things that the phagocytes can do is put a protein coat on that opsonins, and that can assist with getting rid of some of the pathogens. And then again, going back to our natural killers, I've talked about this a couple times in a variety of courses where cytokinins are, in some families, there are a lot more of them, and those are natural cancer fighters. They can lyse cancer cells or other bacteria as well, but in particular, there seems to be in some families a much better ability to identify a cell that is not normal, it is mutated, that is cancerous, and can destroy it. And these natural killers can lock onto some viruses, and they can detect that from their cell surface that it's not something that really belongs, and they can change that cell surface as well. So we have phagocytes, our natural killer cells, and then our third is our inflammatory response. So there are 4 factors to why an inflammatory response is actually a positive thing for the body, as long as it doesn't go too far. It can prevent the spread of, if the body finds there's a damaging agent to that. So you might be exposed to a chemical or exposed to, airborne fungus, for example, and the body can help spread that fungus from getting any further along in your body. The second thing that it can do is your inflammatory response helps in the disposing of debris. So if the phagocytes have done their job and you have, they've broken up material, bacteria, etc., you now have that in your cell and you've got to get rid of it. And so the inflammatory response sends signals that aids in getting rid of some of the dead debris. The inflammatory response also alerts your adaptive immune system that there's an issue and it's going to need some help. And then it sets the baseline for our cell repair. And because I'm aware that these fast little lectures are fast and furious, I'm going to recap the internal defenses. I had gone over the innate surface defenses twice, so I'm going to go over the internal defenses, and we have 3 kinds. We have our phagocytes, we have our natural killers, and we have our inflammatory response. And out of our phagocytes, we have 2 big categories. We have our free macrophages, and they leave the bloodstream and help with getting rid of debris. And then we have our fixed ones that you would find a lot of that in liver. And they also can assist with binding with lysosomes to help get rid of debris. Our natural killers are just that, naturally are in our body. They can help lyse cancer cells or viruses. And finally, with our inflammatory response, we have 4 factors. It prevents the spread of a damaging agent. It'll dispose of debris. It alerts that we need an adaptive immune system and sets the stage for our cell repair. So that's our first lecture on the immune system. Thank you.